All right, folks, here's a rundown of some of the answers to the worksheet that's going to help us for the test tomorrow. Take a look at the first one. Where are the most reactive metals located? Well, first of all, our metals are on the left-hand side of the periodic table. And elements that are reactive tend to either gain electrons really easily or lose electrons really easily. The harder it is for them to gain or lose electrons, the harder it is for them to react. So the elements that are easiest to gain electrons, metals tend to lose electrons. The elements that are easiest to lose electrons are the elements in group 1, or the alkali metals. So specifically within that group, as we saw in class today with the lithium and the sodium, as we go down a group, elements tend to react more violently in the metals. Because as we go down a group within the metals, we're gaining more shells. The distance between the positive protons and the negative electrons is increasing, and therefore there's less and less attraction, so it's easier to lose those electrons. Now, if we compare that to the most reactive nonmetals, well, our nonmetals are on the right-hand side of the periodic table, and they tend to gain electrons, and the elements that are the best at gaining electrons are the group 17, or the halogens. These are really good at gaining electrons because for their period, for their row, they have the most number of protons and therefore are the most attractive to electrons. So they're just magnets for electrons. Specifically, the smallest of the halogens, fluorine, is the most reactive nonmetal. Now, I know you might argue that group 18 is further right on the periodic table. But you have to remember that they don't want any more electrons. They're full. They've got the most number of electrons that they need. So if we look at the number 3, as you go from left to right, atomic radius, well, which does it do? So we're going from left to right. Let's think about it. So as we're going from left to right, we're gaining more protons. More protons means a stronger attraction for the electrons. The electrons are on the outside of the atom. Since the electrons are being attracted to the nucleus more strongly, they're going to be pulled in closer. So as we go from left to right, the atomic radius, or the size of the atom, decreases. And that's because we have more protons in our nucleus for the same number of shells within the same family. Now let's compare that to our group trend. As we travel down a group, what happens to atomic radius? Well, atomic radius is going to increase because if you looked at the electron configuration, elements in the first group, the first row of the first group, just have one shell. Elements in the second row of the first group have 2 shells of electrons. Elements in the third the third period have 3 shells, and so on and so forth. So that means they are getting larger because we are adding shells. And then we touched upon this, I believe, in class. Is a negative ion, is it larger or smaller than a parent atom, and why? So let's just choose an element that becomes a negative ion. So for instance, fluorine. Fluorine has 2 shells, 9 electrons total. 2 of them are going to go in the first shell, and 7 more in our second shell. Fluorine, when it becomes an ion, will gain an electron. So that means we're going to squeeze another, and I didn't really draw this to scale very well, another electron in its outer shell. Well, electrons, being negative, they don't like other electrons. So therefore, they're going to repel new electrons, and that outer shell is going to grow very slightly larger. So negative ions are larger than the atom from which they spring. So fluorine will become a fluorine ion, and because it has that extra electron, those electrons are repelling each other, it's going to make it a little bit larger. Tune in for the next video where we talk about what happens to positive ions.